Good morning. Today we'll be doing a maximum product subarray. This is a very interesting problem. Let's check it out. So in this particular problem, we have a group of numbers and we need to find the maximum product. So in this particular case, we see that the maximum is a 6. And in this particular case, we see that the maximum is a 0. So how do we get this number? How does dynamic program help us? So the first way that we were going to do this is n squared time by multiplying each number with all the other numbers and getting that max number. But of course, that is n squared. And we also, let's check that out. No, let's not check that out. It takes way too long. Okay, so I think you already know what I mean if I just do this first item. So we're going to take 2 times 3 and then take that max. 2 times 3 times negative 2, 2 times 3 times negative 2 times 4, and then we take a 3 and then we multiply by negative 2 and we take a 4, these three numbers, and we multiply these two numbers and the last number, each one by itself first. So 2, 2, 3, 2, 3, negative 2, 4, 3, negative 2, 4, negative 2, 4, and then 4. So that's really slow, n squared time. What we can do to speed this up is to store the running min and max. So how do we see this pattern? One pattern is when you have all positive numbers, the number must increase. So 1, 2, 3, and 4. You see that the number just keeps on increasing. 1, 2, 6, 24. If you see negative numbers, well, there are only 3 types of numbers, I guess. And by looking at, we see all the patterns. So the minimum and maximum here is negative 1 and negative 1. Here, on the other hand, we have 2 and negative 2. Here we have 6 and negative 6. Here we have 24 and negative 24. So you're wondering, how is this possible? How were we able to get these numbers? This number, only one number you can get is negative 1. Here, you can get the negative 2 and 1, so you get 2. Or you can just keep negative 2 to get negative 2. Here, you can multiply negative 3 add negative 2 and get 6, and multiply 2 and negative 3 to get negative 6. Here, you can get 4 times negative 24 to get 24. I mean, negative 6 to get 24, and negative 4 times 6 to get 24. Negative 24. So with that, we see that allows us to store the numbers and get the maximum product. What happens when you get 0 is that we have to reset all these numbers back to the running minimum and running max to 1 so that we can start multiplying again and reset. And with that, we have looked at all 3 different types of numbers: positive numbers, negative numbers, and we handled 0. And with that, I think that handles all the numbers. As we progress through the array, we know when to reset, we know when to use the positive or the negative numbers, and when to use the positive numbers. So the question after we've completed this algorithm is that, how do we figure this out? So let's just start by coding out this algorithm first. So we're going to start with our maximum num in max nums, and we're going to create a running minimum and running maximum. Then for each number, as we've talked about, if n is equal to 0, then we're going to set the running minimum and the running maximum to equal to 1 and 1, then continue. Next, we're gonna calculate the new the new running max. This running max is going to be the current running max times the next number, well, this current number, and the running minimum times this current number, or it could be this current number itself, as you can see here, the 0. Another thing is that you could see 1 and -8. You can see that it's 1. Your running maximum is 1 and your running minimum is 1. If you multiply that, the running maximum and the running minimum with -8, you would have -8 for running max, and you have -8 for running min. Wait, sorry, my bad. Let's try -1. I think that's better. So that would give us 8 and 8. And then if we only took 8 instead, we would have -8. So that's why we need this particular number here. Then we take the new running minimum, which is going to be minimum of these numbers here. The reason why we are not modifying running minimum and running max is that by modifying these numbers, we are affecting the next number. So what I mean by that is, suppose you have updated the running maximum, you're no longer looking at this previous running maximum, you're looking at this current new running maximum. So that's why we have to set our calculations into these temporary variables before we start updating them. Then with that, let's check for the maximum number here and run the new running max against the max number. And with that, we have completed the algorithm and we return the max nums. Great. So how do we come up with this solution? How are you going to find out about this increasing pattern and create a running minimum and running maximum? I think if you have seen this problem before, I had no clue how to approach this problem or even look for the pattern. But in such a case, I believe that you should simplify the problem into its most basic form, either just all positive numbers, all negative numbers, and zeros. Those are 3 possibilities. By simplifying the problem, you might see some patterns that you can use, and also runs your memory of past problems you have done. By looking at that pattern, you might remember that you can keep a running maximum and a running minimum, and using that pattern to get this algorithm, this dynamic programming algorithm. It is a bit creative. I just think that if you do many of these problems, you will start to see this pattern and become more creative with it. So do more algos, simplify a problem, and look for patterns there. And hopefully the idea about the running minimum and the running maximum appears in your head. And that's how I hope that this can be solved during a coding interview. And that is all. So if you enjoyed the video, like and subscribe. If you want more videos, check the link in the description below. And I will see you in the next one. Thank you very much. Have a good one.